Bismillahirrahmanirrahim. Inshallah, today
I think
we will,
recording also started, right?
I don't know. I didn't start a recording. I think you did?
Yeah, I did.
Okay. Inshallah, today we will discuss the sheet metal features, how we can make a face or how we can make a flat pattern for a sheet metal plates. After that, inshallah, we will discuss some orders regarding surfaces and how we can make a thickness for this surface. And sometimes we may need to make surfaces instead of sheet metal parts. And by using surfaces, we can get a sheet metal development too. After that, inshallah, we will discuss how we can make an assembly and add some constraints to this assembly. And we will discuss the physical properties of the parts and how we can get the weight, material, and how we can modify the mechanical properties like the Young's modulus, the density of the material. After that, we will make a parametric model for an assembly for a heli-side nozzle with the reinforced repad. And we will make some examples for the sheet metal during this session, inshallah. Inshallah, we will start with the sheet metal features. Before proceeding with this step, we will need to discuss some important points regarding the sheet metal defaults. When we open Autodesk Inventor, let's create a new project. Okay? That's the first step. And from new, we will create a new project, a single user project, and Day3. And let's define the location of this project on the desktop. Let's add / and Day3. Now let's click finish to create this project. Here, Autodesk Inventor inform you that this path does not exist and the folder of project will be created. Now we are on Day3 project. Now let's click OK. If you try to open a new part, you will find that you can generate a standard part or sheet metal part. In case of starting as a standard part, after that you would like to convert it to a sheet metal part to get the features of the sheet metal. You will find here at the ribbon of 3D model, this icon which gives you the ability to convert the part or the solid part to a sheet metal part. So if you click on this button, you will get this new tab, which is sheet metal tab, and you will find here features of creation of the sheet metal and the modifying options for the sheet metal features. Here we will need to discuss the sheet metal defaults, which controlling the sheet metal rules. And we will discuss that in detail, inshallah, for each feature of those rules. Default, if you open this drop-down list, you will find two standard selections. The first one, which is default, and when you select it, you can figure that the units of the thickness will be defined in inch. Okay. And the second one, which is default in millimeter, the thickness will be defined in millimeter. Here on this list, you will find a list of materials, so you can select the material of your part, like steel, for example. So you can select it from this list like that. And here for the unfold rules, you will find some standard unfold rules. You can create your own unfold rule. The same here for sheet metal rule. You can create your own sheet metal rule. Now let's edit the sheet metal rule and open the form of style to check what are the options available there. So let's move this here and open the form of sheet metal rule. You can figure that you will get this form, which includes the material. So you can modify the material from this list here from the sheet group. You will find the material for this part. So you can select your material from here, and you can define the thickness of this plate. So it looks like extrude order, but in extrude order you can change the thickness. But here in this rule, the sheet blade or the blade thickness is constant for all of the blade. So you will enter it for one time, and it will be used along your modeling of this part. So you can define the thickness from this text box to define the thickness of the sheet metal plate of this part. Okay, and here for mighty and rib and seam gap, those are gaps for the connection if you have the bend corner. So we will discuss the values here. Will be mentioned on the next tabs, but it's an equation from the thickness. Here it's equal the thickness. If you would like to make it double the thickness, you can write your equation here, which is double the thickness or half the thickness, for example. So you can make it like that. So you can make an equation to define the those gaps for rib and seam and miter gaps. Here below for the flat pattern bend angle, you will find two ways to define this angle. Actually, those options for the flat pattern bend angle and the flat pattern punch representation, those are represented on the GXF or DWG drawing, which exported after creating your sheet metal. So the values will appear on your drawing. It is for the fabricator on the workshop. So the value of the bended angle, you will inform him if it's the angle A, which is that value, or B. So he will know that from your drawing that the bended angle, which is the small angle 2 inside, or the outside angle of the bending, like that as per the image. So in your DXF drawing or DWG drawing, you will add on this bend line a notification that bend 90 degree, for example, or 45 degree. So the labor on the workshop will know that 45 degree means A angle. Okay? So that will be the angle. So you will select one of those and inform the labor that this angle referred to A or B. For the bunch, you can represent the bunch in your drawing, the DXF or DWG drawing, like that. So you can select as a 2D sketch, like the presented drawing here, or you can present it as a 2D sketch with a center point, or you can present it as a center point only. So it will appear on the DXF file as one of those selections. Okay, now let's go to the next tab, which is bend. And in the bend tab here, if we come back here after discussing those order, here for the bend tab, you will find some available orders, or from this drop-down list, which is relief shape. You can select the relief shape based on the available machines in your workshop, which the machines for cutting and building. So for the first type, which is straight relief shape, which is like that. So the cut on the blade will be as a straight. Let's make an example for that. Let's keep it straight, and let's make a quick sketch here. Let's make a rectangle with, let's say, 20 millimeters. We will discuss each feature of those in detail, but right now to show you what is the meaning of the result of this one. From here, let's modify this one and make it with width, and make it with 10 millimeters. So when you make this flange on the sheet metal plate, so for this bended area, you will get this circular, which is a straight relief shape, which is that shape. Let's keep the same shape as it is, but we will modify the rule of this one. Let's open the sheet metal rules, and from the bend, let's change it to round. Okay. Before going to round, let's discuss the parameters here. For the straight one, for example, the value A, which is the gap here, it depends on the capabilities of your machines in your workshop, so you can decide the A value. So the A value here comes as a factor from the thickness, and if you would like to define it as a constant value, like 2 millimeters, you can define it like that. Value B, which is the cut to inside, you can define it as a factor or an equation from the thickness, or you can define it as a constant value. The same for C, you can define it manually from here. Now let's click, let's change it to round. After that, you can check or edit those information, define your equations, and if you click on save, okay, sorry, let's change it again from the rules. Let's make it as a thickness, because here, as you can figure, it's 2 inches. So let's make it as a thickness, and click it, save, and let's increase this length a little bit. Let's make it 30. Make finish here, because this distance not enough for 2 inches, so I increased this value, the length of this one, so you can figure the cut will comes in that way, which is round corner. So here the round relief shape for the bending will appear in that shape. In straight it will be straight like that, and in round it will get with a round by that way. There is another selection which is here type. If you have a laser cut or water cut machine, you may get an option to make it without any clearance, but it's not real. But you can make it like that without any clearance for cutting by that way. So you can figure that the cut comes directly to the other edge without any clearances here, like the round or a straight cut here. It's just tear with that edge. So those options for the bending options available during making a flange to an edge. Okay. For the corners, there are many different options for the corner. If you open the corner tab, you will find if you have two bended intersection, so you will get an option to select between different configurations for the two bend intersection, and the same for three bend intersection. If you have three edges make an intersect, you can make the intersect between them and select the different option which suits your fabrication requirements and your workshop capabilities and your machine capabilities. Okay, now let's discuss the corner options, and let's delete this one, and let's make changes this sketch a little bit, and let's make a flange along this one. Okay, let's change the thickness to default 2 millimeter and make it 0.2 millimeter. And from here, let's modify the corner options. For if you have two edges like that, if you take a look, if you have two round edges here, so you can select the intersection between them. Let's apply the changes here, and let's delete this flange now, and let's modify the options of the corner option, and from here let's make it a round cut, and you can modify the relief size. It's an equation, and you can define a certain value. Okay, and now let's click on apply. And if you would like to make a flange here, you can figure that at this corner, when you click on OK, you will get this end, which is a round end. If you get a flat pattern for this one, you can figure that you will get this round cut on the two intersection faces. Let's come back to the model again, and let's change the thickness. Let's make it 2 centimeters and apply. Now it's clear, and I think it's more clear after increasing the thickness. Now this configuration is become clear for you. Now if we make a create flat pattern, you can figure that the round cut will be like that. Now let's come back again and modify the that option and select from the corner. Let's select square cut. So square cut here, you can define it after or before the bend or the radius of the cut. There are two typical shapes for that, which is trim to bend. It gives you a square shape, but the end of this square is to the bend of the trim. But a square, you can define the value of the relief size. Now let's click on save and apply this. We get a flat pattern. You can figure that the intersect area takes that shape, which is square shape, that one. And if you get the flat pattern, you can figure that the end here, the end comes after the bend line. You can make it, you can control this value, okay, for this cut. Let's come back to the 3D model. So the square shape and trim to bend, they are looks like each other, but that one, which is trim to bend, make the cut up to this line only. So this line will comes here. So let's try that. So let's open the sheet metal defaults, and let's open this one on the from corners. Let's select trim to bend and click save. Now, when we close this one and get the flat pattern, you can figure that the cut comes to the bend end like that. Okay, I hope this one becomes clear. Now let's come back to the corner and select another type, which is tier. So the tier will give you the cut without any clearances. Okay, let's apply that. And now you can figure that no clearances here, square or round or something like that. So let's come back to the 3D model. So the cut will be a tier like that. Okay, let's check another option for the bend, which is linear weld. So the cut will be like a V groove from the bend to the other bend. And if we accept that and get the flat pattern, you can figure that you have a line here from the start of bend up to the end of bend here. And the same for the other side, inclined line, which is that line connected between the start of this bend up to this bend like that. So that's the option of in bending, which is linear weld. Now let's select arc weld. It seems like it, but with a straight edge at the end here. Let's accept it. And let's get the sheet metal development of this one. You can figure that it comes with an arc and with straight edge at here. Now let's try another one. And from corners, let's select laser weld cut and click accept. Now you can figure that you have this one. It's based on the tools that you are using in cutting and the tools that you will using during the bending. Okay. So those are the types of two-bend intersection. So you can select the suitable one based on the capabilities of your workshop. Here, if you have three bend intersection. Now let's come back to the 3D model here. And for let's change this flange and let's remove one of those faces. Now to make three edges, we have this shape, and from flange, let's select those edges. Now we have three corners. Okay, we have a corner which is that face, and the face at the top here, and the other face on the other side. So when you click apply, you will get this corner cut. We get the flat batter. We will get that shape. So you can control the shape of this intersect between four different types, which is no replacement, and intersection, full round, and round with radius. So let's change the types and check the difference between the configurations. From here, let's select no replacement, and you can figure that you will get this rectangular cut here. And if we click save and get the flat batter, you will get this shape at the cut between the intersect of the three faces. Now let's come back to the 3D model and modify this one to another option, which is intersect. And you can figure that those are straight edges, no rectangular or circular end at the intersect here. Now let's accept that and get sheet metal development. You can figure that you have a straight lines here without any clearances. Now let's change that type to another one. So from corner, let's select full round. As you can see here in this image, you will get a tangent arc to those lines up to the bend line. So from here, let's click on accept, and when you get the flat batter, you have an tangent arc to those cut lines here. Another remaining option for three faces intersect, so or three bended intersect from round with radius. So you can control the radius value as mentioned when you click save and get the flat pattern of this part. You can control the radius of this one. It looks like the previous one, but you will have the ability to change the radius from here. Okay, now we discuss the features of the bend, which is on the second tab here. So we discuss the three tabs on the default sheet metal defaults. So we discuss those features, but we still need to discuss the unfold rules, and we discuss the bend options and the parameters available here for straight or round. We discuss those parameters and how you can change them. And from corners, we discuss the two bend intersect options and three bend intersect options. Now let's discuss the unroll factor, and actually this one is very important during making the sheet metal development. And this factor you can select between different options, and you can create your own options for unroll rules. Let's discuss the first one, which is K factor. If you open the K factor, you will find the value of the K factor. You can define it as a linear or bend table based on a bend table or a custom equation. So for the first option, which is linear one, if we open this slide here, for the unfold method, for the linear method, you can define the K factor. K factor takes the values from 1 up to from 0 up to 1. The maximum value is 1 and the minimum value is 0. Here for this sketch, you can figure that let's see it a little bit. From here, you can figure that the length of this part, we didn't make any ruling on it. So the length of this part is constant, no changes on it. And that one the same, because it's straight. The problem appears when we make a bending or forming a part of the plate. Because if you take a look to inside, we have a compressed surface here. So this line takes a value smaller than the actual value of the plate length. And the same for the outer surface. It's become tension. Okay, so it takes a value greater than the actual value of the plate. Here for a line between the inside and outside, we have a line between them. And the location of this line, which is the K factor, which takes a value from 0, which is the inside, up to the end, which is the outside line. This line location or the value of the K factor based on or depends on some properties for the material and sometimes for the different thicknesses for this material. So this option, usually you can use it for large formed blades. But if you make small parts with a very or a high accurate clearance, this option will not be a good one for use, because you may get a difference between the actual bending values, because the value here which you will enter, for example, in the industry of oil and gas, if we have a shell plate and make a rolling for it, we use the mid line. So that line will be on the middle. So the K factor becomes 0.5. So that line, which is the neutral line, that line gives you the actual length of this plate. So if you measure the inside value, you will get a small value. And if you smaller than value from the neutral line, and for the outer line, you will get a value more than the actual value of the plate. So the neutral line defining the actual length of the plate before deforming and after deforming. So the K factor, you can define it as 0.5, for example, in our industry. If you in oil and gas industry, if you would like to make a shell forming or a nozzle blade forming, you can use this value as 0.5. But as mentioned, if you would like to make a very accurate parts, small parts with a very accurate clearance and tolerances, that option will not give you a good result, because actually, as mentioned, the thickness will change that factor. So with the small thicknesses, you will get another value for this factor from the other high thicknesses. So 1 millimeter thickness will not give you the same K factor for 100 millimeter thickness for the same material. And the same if you change the material for the copper, aluminum, and steel, the K factor will change. So we can use it, as mentioned, as 0.5 in some cases. But if you would like to make very high accurate parts with very high accurate clearance, you will not use the linear method. Okay, so let's go to the next type of unfold method. For here, you can define a table. You will fill it by hand. This table, you can get it as a report after making some testing, or if you have this list already, you can define the different thicknesses for the same material. And for the bending angle, with each bend angle, you can define the bend radius and the K factor for that, with different thicknesses and different bend angles. So at 90 degree, you will get a value. With 60 degree, you will get another value, like that. The third way to define the unfold method, which is the most complicated one and the most accurate one, if you would like to make very high accurate tolerances and clearances for cutting and bending, and that's for small, very small parts in not looks like the shell plates or nozzle plates. It's for the high accurate parts with small dimensions and small tolerances. You will go to the third type of unfold method, which is custom equation method, which is give you some parameters like the bend angle, the thickness of the part, the radius of the bending, natural surface, and development length. Inside that, you will find 4 types of equation. The first one, which is bend allowance, and bend compensation, and bend deduction, and K factor. Each one of those, if you take a look for the bend allowance, for example, here you can figure that the length of this straight part is without no change, and that one without no change. And here you have the red line inside, which is the natural line with the actual length of this bend. As mentioned, the inside surface will be compressed and the outside one will be tension. So the lengths of them is not accurate, but we have a natural line here inside. And to define the location of this one as a K factor, where it is inside the thickness, we can make an equation like this. Okay, so the length of that one, if you take a look to the equation here, which is L1 plus L2 plus V, and V will be calculated based on that. So the V, which is the length of the bended line, the actual length, can be defined with this equation from 0 up to 90 degrees. If you increase the bending angle more than 90 degrees, you will use another equation to calculate the V angle. So from 90 to 165, you can use this equation. You can define those equations as per your experience with this material. So you can define the equations of that by using the bend allowance in that case. And for the bend compression, you can figure that in the bend compression, if you take a look to this image, the L1 and L2, those are the length of those lines up to the intersect between them, not the straight line like this one. If you take a look, the L is a straight line here, but the L is the total line up to the intersect with L2. After that, you can calculate the bend compression as per the equation here. So L1 plus L2 plus B. And for the bend reduction, you will use this equation. And for the K factor, you can use those equations. So you, as mentioned, for the third type, which is custom equation method, you can define the used equation for that. How we can change between them from Autodesk Inventor here. So if you you can figure that from the list here of the sheet metal rule. You will find a sheet metal unfold, the same included here on the list on the left-hand side, and you can select between default factor and bended compression factor. If you select it, you can figure that you can select between custom equation, and you can select between bend allowance, bend compensation, and bend deduction or K factor. So you can change here, and if you would like to edit the equation, you can open it like that and modify the equation and write the correct value for your calculation right here. The second type, which is bend linear, as mentioned, you can add a different thicknesses like 2 millimeters here, 1 millimeter, 3 millimeter, and from here you can define the open angle with the bend radius. So you can define the angle here with, let's say, 45 degrees. If you would like to insert another row, you can define the bend angle up to 90 degrees and define the bend radius here. So those are the ways to define the sheet metal unfold. Okay, let's select the K factor type with a linear method. Okay, and define this one as half or 0.4. It depends on the material that you are using, but actually through our samples today, we can use it as 0.5. Now let's close this and go to the next slide. And now let's discuss after modifying the sheet metal or the default setting for the sheet metal. Now we can proceed with the features of the sheet metal, how we can make a sheet metal parts, and discuss the available features for that and how we can use them. Now after, let's close this one. Sorry, let's close it, don't save. And let's create a new sheet metal part from here. Create a new sheet metal. And now if you try to click, now you will find some features that are active like face, contour, flange, loft, and contour rule. If you click on one of them, you will get this message, which is you need a sketch to start your feature. So let's click on OK, and now let's create a 2D sketch. And from here, let's select this face. Let's create a rectangle like that, and define the dimensions. Let's make this one as 100, and the height is 50. Let's click on Finish Sketch. Now, if you click or select the face, you will get a feature like it looks like extrude. But in extrude, you have the ability to define the thickness of the extrude. But in the sheet metal, you already defined it from the sheet metal defaults. As we discussed on the sheet metal default, you will need to define the thickness of the blade, because the thickness will be used along this part. If you use any feature, you will use this constant value for the thickness. But in extrude feature, you can change the extrude value. So it's the default here will be the thickness. You have an option to make this this face comes over the plane and comes back over the plan view, plan or front or back of the view, and you can make it equal. It looks like extrude feature. From here, you can make it front, back, or on the middle. Okay, so let's make it on the front of the plan, and let's click on OK. Now we have this face, which we can make it with a sketch. If you let's make another part. So you can make any sketch you would like, but should be a closed sketch. So we can make something like that. Any closed sketch like that. If you would like to add fillets, for example, so let's add an arc from here to there, and make this arc tangent from here to there, and let's make this one as a construction line. If you click on Finish, now when you click Face, you will select all of that face. So you will need to make a closed sketch to create this face. Now let's go to the next feature, which is flange. So here, for that one, we discuss the options of offset direction over the plane, back of the plan, and middle of the plan. Now the flange options. Let's select the flange option, and from here, let's select this one, and let's take a look from the side view here. And let's minimize the distance, which is the length of this edge. Let's make it 5, like that. And you can get a preview for this part. From here, you can control the flange angle. You can make it like that. And you configure that the angle defined here based on, so 135 degrees, based on the selection of the definition here. Or if you, let's open that one, which is angle A. So the angle A will be defined from the outside like that. So the value will you enter, it will be measured from here. So let's select again this edge, and from here select flange and come back again. So the A value 135 degrees will be measured from here. So you will get this one if you make it 45 degrees, you will get it like that. So, and the bend radius, you can modify it, make it 90 degree. And for the bend radius, you can modify it as a default value from the unfold options, because already all information you defined it on the sheet metal defaults already stored here. If you would like to modify something special for this corner, you can do it. So the bend radius will be calculated automatically from the equations that you defined it from the sheet metal defaults. And here's some other options for the height data. As you can figure, if we take this here and make a zoom to those features, you can figure that the length, which is we mentioned it here, which is 5 millimeters, will be measured from the intersect of the extension of those two lines. Okay, but here for the second one, it will be measured from the end of that line up to the tangent arc of the bend. Okay, and that one, that's for the middle, and that one for the tangent end of the bend. Now let's change that. Let's reduce this one to 2 millimeters and increase you like that. Now let's change this one. So if you make it 135 and let's increase this to 4 like that. Now if we change this value to the tangent line, you can figure that the extent is increased because the value here is measured to the intersect. For the first value, it's a measure to the intersect between the lines. So we take the screen like that, and if you extend that line from here, sorry, extend that line from here to there. So the length, which is 4 millimeters, will be measured from here to there. Okay, but with the third option, it will be measured from the tan edge here. So the value, which is 4, will be measured from that point. So you will get a more length. And for the second option, it will be measured from the normal line. So you will get another one. So that value will be defined as for those cases which is high datum. So the datum point will be from the intersect point here, or from the tangent line, or from the neutral line. So if you change it from the bend form intersection, you will get a larger length here, and if you modify it to the tangent line, you will get it like that. So those are the bend options or high datum options. Let's make it 90 degree again and discuss the other options for bend options. Now, if we get a new print screen, and here for the bend options, those options, you can figure that the bend will be tangent to the line here, which is that line. We make that. So the line will be tangent to the from outside, but that one, the line, the bend will start after the end like that. So if from here, that's the tangent line here, parallel to that one. But if we make it like that, so we will keep the location of this one and make the bend before it. So you can figure that we kept this length and make the bend at the end, but that one you make the bend after the end, so the total height of this part will change. The same you can make it for the inner surface here. So the line will be you can figure that line parallel to that one, and for that one it will be with the tangent arc. It will appear if you change this value. You change this value, so the tangent will be with the extension of this line. Okay, now let's make it 100 degree and click on. Okay. Now we discuss the options of the face and flange. Now let's go to the next feature, which is contour, flange, and sorry, that's loft. Is a contour, flange, and loft. So let's go to the contour flange. Let's close this one and create a new sheet metal part. And for the contour, you will need to draw the contour of the part. Like if you have just draw a lines like that one. And if you click finish and select contour flange, you will get that shape like that. Okay. And if you take a look to the options here, that's the offset direction. So it's below the line, and here on the above the selected line. So again, here that's the lines that you sketch, and from here you can figure that you can change the direction up or down, or make this line on the middle. So this line you can make it at the half thickness of the sketch. So you will make half thickness above the sketch and half thickness above, below the sketch. From here you can change the distance. Let's make it 10 millimeters, so you can control the projection of this one from that value. By the same way, if you take a look to that plan, here it's over the plan, and you can control it to make all of that behind the plan, and you can make it half front and half back of the plan, like that. So those options give you the ability to control all the feature location above or back of the plan, but that one gives you the offset of the thickness. It's above the line or below the line, or it's half and half above and bottom of the line. So that's the contour flange. For the loft flange, let's create a new part, sheet metal part, and let's draw a rectangle at the bottom. Let's make it a centered one. Let's define this height as 50, the other 500, like that, and let's click finish. And now let's make a work plan from here with an offset, let's say 50 millimeters, and let's create a new circle. And this circle, we will make it with an offset from here to there with 25 millimeters, and let's define this one as 35 millimeters, and make it aligned in a horizontal position with the center line, or we could make it with an offset. So let's define this offset as 5 millimeters, and let's define that as a vertical, like that. So let's finish a sketch. Now we have two sketches, one for a circle and one for a rectangle, and by using the loft option, we will connect between them like that. So you can figure that you will get that shape for this reducer with a rectangular end and a circular end. And you will find some options here for, let's discuss them. If we take a look to the image from for this view from the bottom view, you can figure that you can control the offset to make those lines as inside lines, and you can make them as the outer lines. So the surface or the contour line that you make it or draw it, it will be the outer face or the inner face, or it's on the middle, so you can make the thickness half above the sketch and half below the sketch, so you can control the thickness or the offset direction for this part by that way. So if you take a look for this reducer, we make an offset for this circle into with two values from the center line of the rectangle, so it's offset by that way. Here for the output, you have two selection orders. The first one, which is die format option. The die format option, in that case, you will need to use the die forming to get this those surfaces. So here you can get this smooth configuration for this one, this loft by that way with a smooth surface, and you can make it. You can make it by using the second way, which is press break. Okay, so with this press break, you will get some other options for defining this press break by chord tolerance or face angle or phase distance. Okay, so from here, if you take a look to that one, you will not get a circular or a complete circular end here. You will get it as edges. So to make it smooth, you will need to increase those segments, and you can control that by increasing the chord tolerance. So that's the tolerance. If we minimize it, you will get this circle smoother than the first option. If you increase it for one, for example, for one instead of half, you can figure that the smoothness become low. If we make it 1.5, the smoothness become low. So you will get a shape looks like a hexagon, not a circle. The second way, by defining the face angle, so you can minimize this face angle to increase the faces that you have. So if you make it 5 angles, so you will increase the number of faces, but that will makes the labor in your workshop make a lot of breaks lines to get this configuration and get a smooth circle end. Okay, the third one by factor distance, so you can minimize that to increase the number of faces. One more option here for the end option. Here the end will be a smooth end in case of deselecting converge option. Let's click on yes. Now if you take a look to the end here, you will figure that this end become smooth. But if you if it's not an option in your workshop to make it like that, you can select that option, and that one will give you the ability to make a cut to make it suits the fabrication capabilities in your workshop. And you can figure that the same here for those corners. You will get a cut, and those are the bend lines that you will make it by using the press. Okay, and you can define it by arc length or angle. So the labor in your workshop will use the press tool to make a bending lines. So those faces are straight faces, not like the previous feature, which is die form. So in die form, the face become smooth, but here you divided the smooth face to straight faces to get a circular end at the top by that way. So that's the loft option for making sheet metal plates. Now let's discuss the contour rule. The contour rule looks like the revolve order. It looks like the revolve order, but give you some other options. Here, let's create a new part. So from parts, let's create a new sheet metal part. And from sketch, let's select a plan. And from here, let's make a center line. Convert this center line to this line to a center line type. And from here, let's make another line. Define the diameter of this one. Let's make it meters, and let's click Finish Sketch. Now, if you select Contour Rule, you will get this revolve feature, so you can change it up 180 degrees like that. And let's increase the thickness a little bit to show you something important. Let's make it 4 millimeters, for example, and come back to Rule section. Here you can see a red surface with an extension. Here, this red surface shows the neutral line, which is indicate the actual length of this plate before forming. Okay, and you will get the value of this one here from this one, which is unruled length. So the value of this one will be like that. So if we come back to the sheet metal and modify this rule and make the K factor here, let's make it 0.2, for example, and click on Save. So, and open the contour flange, you can figure that the neutral line takes this value as discussed here on this slide. Here the K factor takes a value between 0 and 1 from the end surface of the bend up to the outside surface of the bend. So if you change it to 0.2, for example, you can figure that the difference between the value from the neutral line here up to the end and the neutral line between to the inside. So this value is 0.2 from the thickness, and that value will be 0.8 from the thickness. And the chord length or the unruled length will be calculated from that neutral line. So if we change it again to 0.8, let's change it to 0.8. So let's come back to the K factor and modify the K factor value. Let's make it 0.8 and click Save. Now if we change the contour rule, you can figure that now it's become near to the outside. So the inner value of the K factor will be 0.8, and here to the outside will be 0.2. So, and you can figure that the unruled length will be changed rather than the previous value. Okay, let's get it back again to 0.5. And by the way, you can open that directly from the K factor here instead of going to from view to another view. You can open it from the K factor viewport. So if we make a contour line, you will get that the neutral line at the middle of the plane and plan, and here the chord length or the unruled length of this plate appears here. Okay, now let's make another contour rule, but here we make a straight edge. Now let's delete this one and keep the sketch, and let's modify on this sketch. Let's come back to this sketch and let's add some other contours like that. Let's delete those. Okay, and click on Finish. And let's minimize the thickness again to make it as a default thickness, which is 0.5. Now, if you click on Contour, you will get this rolled section around this axis. It looks like the revolve as we discussed. And here you can figure out the neutral line, which is that surface which gives you the unrolled length, comes between the outside here of that one and that one, not the thickness, because you have a section here differ from that one, and that will appear if we will appear clearly if we minimize this one and increase this one a little bit. So the neutral line will appear. Let's make that as a construction line, because we make it 0.5, the K factor. So the neutral line should be at that one. So here you have the neutral line between those values, and here the unrolled lens. Now, if you would like to get the flat pattern, you will get the bend lines on those directions. So that's the main plate which give you the result of that one. So let's come back to the fold, and here that's the unrolled surface for that one. Okay, that's regarding the control rule. Now let's create a new part as a sheet metal part. Let's make a face. Finish. And create a face. So here for the hem order, let's come back to the hem feature. You will find different options for the hem end, which is single, teardrop, rolled, and double. So if you select this one, for example, for the single hem end, like that, you can make this hem like that, and you can flip it on the other direction. So that will give you the ability to change the hem location. You can change the gap value. So the gap, which is the distance between that line and that line. So if we make it, let's say 2 millimeters, so the gap of hem will increase like that. And the length at the end will be 4 times the thickness. So you can change this value, you can make it 2 times or 6 times like that. Okay, another option for the teardrop, so you can make this end with a teardrop end like that. The same option, you can change the orientation of this one, changing the length or the rotated angle. For example, let's make it 20 like that, so you can change. So as mentioned, the angle measured from let's take a print screen to show you what I would like to say here. Let's take a print screen and come back here. So if we make a line at the end here, let's increase the thickness of this one. We have a line here, the end line, and that one tangent here. So the angle between here and there, it's 202. Okay. Yeah, I hope it's okay. It's the on the other side. Sorry, that because here if you make it 180 degree, the previous angle that's 0 degree, and if you like that 90 degree, 180. So if you make it 180 and measure that one, it's not that angle. Sorry, it's the angle from here to there, from the outside angle, all that angle, not the inclination angle here. Because if you make it, let's say, make it 180, okay, 95, like that. So the angle from that surface to here, it's more than 180 degrees. So if you increase it to 200 or 220, so you measure the angle from that face to that face. So no need to extend the red line. So the angle measured from that face up to that face. Okay, that's the angle from here to there. Okay, which defined it as mentioned before in that from that option, which is that angle A, because you are select the report bend angle A. Okay, let's come back to the hem feature and select the rolled type, and from the rolled type you can change the angle and bend radius, and for the double hem shape you can make it like that. So you can define the gap from here and gap in that way, so you can get the hem feature like that. After that you can get the sheet metal development of this part with the bending lines and bending radiuses. Okay, now let's go to the next one, which is bend and fold features. Okay, now let's make a new part, sheet metal part, and let's create a face here. Finish and make it as a face. Let's make another work plan from here to there with meters, and let's make another face. Okay, let's make it here and minimize it a little bit. We have another face like that. Finish and make that one as another face. Now by using the bend order, so if you select this edge, for example, with that edge, you can figure that you can make a bend between them like that, connect between those plates by using this one. For the first option, you can make it 90 degree without extension, without extending the top one. So if you click on OK, you will get the result like that. And as discussed here, for the connection here, you decide the configuration of this one based on the bend configuration as a straight or round or tear. Okay. Now, let's come back to this feature, and you will find another available option in that case, which is you can make it with extended length. So here you will extend the top plate, so you will extend the shortened one to the other one. If you click OK, you can figure that you extend this one to suit the bottom plate. Okay, another option, let's remove this one again and make it full radius. Now you can make a connection between them with a full radius without extending this one, the top plate. Okay, so if you click OK, you will make a full round connection between them without making an extension for the top plate, and you will get this result. And if you make it with extend length, so you can flip and extend this length, so you will extend the top plate and you will get that result by that way without making a cut at the end here. Another options, if we delete this one and make the bend radius, and if you select an opposite angle, so let's select this one with that one, so you can figure that you can make an opposite direction, so you will get fixed another options. For the previous one, you will get full radius and 90 degree, but here with that one, with the opposite direction edges, you will get that one. If you click OK, you will get this error because the direction of that one is not suits it. But if you make this one, if you make the fixed edge, you can connect between those edges by that way. So you can connect between those edges by that way, and you can, if you click on apply, you can make an edge like a Z shape or like a Z shape by that way for the loft flange. Okay. Another option for the fold, if we delete that one and that one. Okay, and if we delete this bend and come back to this face, and let's make another rectangle here and make this one construction line. Okay, and let's click finish sketch. Now we have this face. Okay, so we will discuss in this sample the fold option. Now, if we select this face and make a line from here to there, okay, and click finish sketch. Now, if you would like to make a fold for this one, so if you take a look to the fold option and click on that one, you will get an option to fold or fold the blade around a line. So here you can control the flip direction, flip the left part or the right part. You can figure that the arrows here shows that the right part will be flipped. If you click on apply, the right part will be flipped, but the left part will keep as it is. And let's delete it and use the fold part fold option again and select that one. But from here we will flip the side, so you can flip the side to make the left side will be flipped. So if you click on apply, you will get that result. And by the way, you can control the flip direction up or down. So those arrows, you can figure that you can flip the left part to down like that, or make it up to top like that. The same if we delete this one, keep the sketch, and unfold the other side, you can make it flip to up or down by that way. You can make this fold for sorry, let's delete it. You can make this fold along the plates. If we make a line like that, click on sketch. If you make a fold for that part, you can control the unfold angle from here and click on save. So you will fold those edges like that. Okay, that's regarding the fold options and how you can control the selected part left or right, and the direction of flipping up or down. Here for the fold direction, the calculation of this one, here you can make the fold becomes after the fillet, or from the end of the fillet, or that's the start of the fillet, end of the fillet, or on the middle of the fillet. Sorry. So from those options, you can control the fold location. If you make it from the end, it will be at the end of this fold. So the fold starts from here. Okay, so the fold starts from that line. And if you make it from the end, you can figure that the bend starts from here, like that. Or you can make it at the center, so the lines that you sketch will be the bend line, like that. Okay, now let's discuss some other features for modifying. Now we discuss the features of modeling. And on the samples, inshallah, in this session, we will make some real samples for simple shapes, and complicated shapes needs a lot of sketches. And we will make a mix between the available features to get a good understand for how to mix between those features to get the correct configuration and correct arrangement for the sheet metal. Here for the modifying features, we will discuss the cut features cut feature options. And from here, let's close this one. Let's open a new sheet metal part. So from new, let's select new sheet metal part. Let's create a new sketch, select a plan. After that, let's make roughly sketch like that. click Finish Sketch. Now let's select a contour plan, define that value, make it equal in the two pieces, like that. Change the thickness of this plate. Let's make it 4 millimeters. Okay. Now let's make a cut. So if you select it, you will get this message because you should have a sketch. So to create a sketch, select one of those surfaces. After that, select Create 2D Sketch. Now we would like to create a cut along this flat pattern or this part. So how to do that? Here, if we make a slot like this, slot hole, and click Finish Sketch. Now if you click on Cut and try to make a cut to this part, if you select those options without selecting one of those checkboxes, you will get this cut on that surface only. But if you would like to make this cut coming through the plate itself, so you will need to make a cut cross bend to make it takes the actual cut on the plate after getting a pattern of it. Now let's make another cut. So let's undo this one, and from here let's add some other slots here and there. And now we would like to get a flat pattern for all of those surfaces here. Now there is a new option, we will learn it, which is Project Flat Pattern. By selecting this one, you can get a flat pattern for those surfaces like that, and for the last one here. So now you can figure that you get a complete flat pattern for this cut, and when you make a flat pattern, a cut by using this flat pattern, like selecting a cut and select those areas again, like that, and when you make it cross bend area, you can figure that you will make a cut along this part by that way. So this type of making a project surface give you the ability to draw the flat pattern of all of the part to put the cuts in the right place. Now let's check the second order, which is corner seam. Now let's close this one. Let's create a new sheet metal part, and let's create a sketch and make a flat surface. Click Finish Sketch. Click to create the surface and make those flanges here and there. Now let's modify this one and make it shorter. So from here we could make it offset like that and define the offset from each end. So from this end we will make it 10 millimeters like that, and then let's make another flange for the other side. Let's make it with 145 degrees, or let's make it 60 degree like that, and make it with a width. Let's define this width as 30 millimeters. Let's make it a little bit smaller, so 25, and click OK. Now we have those edges like that, and by using the corner you can modify the seam end between the end edges here. If you take a look from that side, you will find a gap here between this end and that end, and from the other side you have the same gap. But if you would like to make one of them flipped over the other, so if you select this one, okay, which is overlap, you can make that end extended up to the last surface here, and that one has a gap. And if you would like to flip that, just click reverse overlap to make this one extended to the end and that one with a gap. Let's click on apply. Now you have this end like that. Now let's try to use another feature, which is the bunch tool. Okay, now if we come here and create a new sketch and put a point here. After clicking on finish sketch, you can add a bunch tool. So from here you can select the bunch cut. So you can select between some of the standard bunch tools like that. Select the suitable one for your case and click OK to get the suitable one, and you can create your bunch tool as per your request in your workshop. Now let's try another order, which is rib. Okay, let's create a new sheet metal part. From here, let's create a rectangle with 50 millimeters width and 100 millimeter length. Click finish. Let's create a work plan from that surface with 50 millimeters offset. After that, create a new sketch and draw a circle from here. Define the horizontal offset from here to 30 millimeters and 5 millimeters from here. Define the diameter and make it, let's say, 30 millimeters. After that, click finish sketch. Now let's make this plane invisible, and from here let's make a loft and select the die format. Select those faces, those sketches to make this die form. Now if you would like to make a cut on one of those faces, you can do that by creating, if you have this sketch, you can add, let's say, a point here to use it as a reference point for a welding line, and let's make this one as a visible one. Now you can use the rib and select the inner face, so we need to select the inner face from here. After that, select a point to make a rib on that surface, or you can make direct selecting an edge. So from rib you can select one of those edges to make a rib along one of those edges like that, and click on OK. Now if you get the flat pattern, you will get a flat pattern for this part like that. Let's make another part, but that time let's make two circles as a cone. This one will be 100 millimeter and click finish. Now let's make another work plan with 50 millimeters offset. Let's create another circle with 50 millimeters diameter, and now click finish. Let's connect between those sketches by using loft and select die format. Now if you make this one invisible, now let's select the top sketch and add a node right here and define the orientation of this one. So let's add two lines, one of them go through this node, and let's define the orientation of this node as 10 degrees. Now if you select, let's make this sketch visible, and from rib, if you select the inside face and select this node, you will get a rib along this face like that, and if you click OK, get the flat pattern, you will get the flat pattern by that way. But let's make another node on the bottom sketch. So from here, let's select the bottom sketch, and let's add another node located, let's say, on another degree. So let's connect the center line to here, and let's make this angle 160. Now if you click save, you will get one point at the top, another one at the bottom. Okay, now let's connect between them. So by using a rib, let's select the inner surface, and from here let's select 2 points. So select this point and the other point which is located here. So you can figure that you can make an angle or a rotated weld line or cut line on that face anytime you would like to modify the orientation. So let's make this as 90 degree. So you will get a cut like that along the path. So let's make the sketches here visible. Now if you get the flat pattern for this part, you will get it like that. So let's come back again for the model. And now we have this cut or the rib along the cone with a tilted angle, because we have a start location and end location like that. Now let's discuss the feature of unfold. Here, the fold and unfold. Now let's close those parts. From here, let's create a new sheet metal part. And now let's create another contour like that. And let's create a contour flange by that way. And from here, let's make unfold. So to use this order, just select a face. After that, you can select the bend area. And if you click on apply, you will get this surface unfolded. And you can add more than one bend. So from here, you can add other bends. So you will get this bend, another bend here, and that one, that one. So by that way, you convert the 3D bended shape to a flat shape like that, and you still keeping the bending areas here. Now if you would like to make a cut through that face, if you, for example, create a slot hole like that one, make another slot hole like that, another slot here like that. Let's click finish. Now if you click on cut and select the closed areas here and make it cut cross bend, now you get a cut here. So by that way, you unfold the 3D model to make it on as a flat model to create your cut. After that, you will need to make a refold again. So from here, let's select this one, select the first plane, and again unfold all of your model to get it back as the first case. So when you click on OK, you will get your model unfolded again with the cut. So here the difference between creating a sketch, which is making using the project flat pattern, which we used it from minutes ago. This option gives you the ability to create the flat pattern as a sketch. So over this sketch, you can use it to create your cut. After that, by using the cut order, you can flip the cutting on the 3D model. And here for the unfold, or for the fold and unfold, you make unfold for the 3D model, for the 3D bended model. So I hope this point become clear, which is the difference between the project flat pattern and the unfold feature. Okay, now let's make a sample project. Let's make this cyclone part as a rectangular reducer. So from here, let's create a new project. So from new, let's create a new sheet metal part. And from here, let's modify the properties of this one. Let's make the material as steel. And from here, let's define the default material. Make the K factor as 0.5. Okay, save this and move to the defaults. Change the thickness to 2 millimeters and click save and click on OK. Now let's make a sketch on that plane, and from here let's select a rectangular shape. Define this one as 100 millimeters and that one 200 millimeters. Let's make both of them as 200. So let's change that one. And from here, if you would like to make a contour, you will not be able to select a closed face. It should be an open sketch. So we need to make a cut here. Define this cut as 1 millimeter. Now if we click on cut, and move that one as construction line. Now by that way you can make a contour. So if we select this one and define the contour length to be 200 millimeters and extend it by that way and click on apply, we will get that one. Let's change the color of the material to steel. Now if we add flanges, let's select the inner edges from here like that, and let's change the angle here. Let's make it 45 degrees and increase this one to 100 millimeters. Okay, so the shape will be converted to that shape. After that, let's add another flange, but that time let's select the out edges from here, change this to be 20 millimeters. Now we have this cyclone cut. Now let's create a flat pattern. So by that way you can define the get the flat pattern of this shape. Let's create a new part. So from here, let's create that part. So from here, let's create a new sheet metal part. And from here, let's create a new sketch. Let's define the contour shape. So from here, define those faces, convert this line to a center line, define that distance to be 20, that one as 20 millimeters, define the angle to be 135, the length of this one, aligned. So let's add aligned dimension to be 20, and that one 20 millimeters. Now let's finish a sketch and create a contour. Now let's make it up and down and make it 10 millimeters. Now we have this shape. Let's create another sketch on that side. So from here, let's select line, select the end here, and create a curve like that, and get the end here. Make this line tangent to that one. Let's define the diameter 10 millimeters and define the offset from here to there as 10 millimeters, from here to there as 15. Okay, decrease this one a little bit. Now if you click on finish, and by selecting a face, automatically you will get it on the right direction, and you can flip it, but it's not, that case is not correct. We need it on the correct direction like that. Now let's make a cut through that face. So from here, let's select that face and create a new sketch, and by using the project geometry for the flat pattern, let's create all the flat pattern here, and let's create a circle with a diameter of 12 millimeters, and from here let's create a slot hole like that. Defined the height to be 2 millimeters with thickness 1 millimeter. Make this line vertical, so with the center line of the circle. Define this offset to be 3 millimeters, and after that let's rotate this around that point of the circle with 8 times. After that, let's create a new circle with a diameter of 18 millimeters. After that, create a bold circle diameter. So this circle is not located on the center, so to center it, let's check, click on that and make it centered with that circle. Okay, we need to define this one, the diameter, so let's make it 15 and convert this line to a construction line, and from here let's make a slot hole like that. Define the width from here 1 millimeter, and let's define the angle, so we can select that. We need another line here, so we can measure it from here to there, from here to there. So we can define this to be 30 millimeters and make the midpoint of this arc vertical here to here. Okay, Now let's make another slot hole along that one. So let's create slot hole like this. Let's make those points on the same level. Now let's click on finish. Now when you select cut and select that face, from here let's select those shapes. Okay, and we need to make a pattern from this, so let's come back again to the model and select that slot. Okay, and make a circular pattern around the center point. Let's make it 4 pieces and click on OK. And let's come back to cut, and from cut let's select those edges. Okay, and one more cut and make it cross bended line, so we will get a cut like this. Now let's make a mirror for all of this solid around one of the origin planes. So you can select the origin plane directly from here, or you can select it from the form itself. So let's select that. So from here you can select one of the origin planes like that. From here you can make it around X, Y plane. Now let's make a bend between that edge and that edge. Okay, and by using flange, let's select the inner edges like that and define the edges like that. And from here, let's make that one with a width with, let's say, 7 millimeters. The same for that one. Let's make it with a width 7 millimeters. And let's click on OK. Now we have a cut on that part like that, and you can make get the flat pattern of this one by clicking on this and get the flat pattern of this shape easily. Okay, now let's go to let's create let's discuss another shapes for the surface shapes. Okay, and in here let's discuss how to make a rolled surface, how to create a stitch, to make a stitch between surfaces, and how to make a patch, extrude, and trim. So let's create a new solid part, and from here let's create a center line, and let's make contour lines like that. And from revolve, let's select a surface, and from here select the surface and the select the surface and the rotational axis. So from here select the profile. After that, select the X to make a complete revolve for that one. Here, let's remove the transparency of this part to be to see it clearly. And from here, if you make a rolled surface and select this edge, you can figure that you can make you can extend that face like that and change the angle. So from here you can change this angle inside or outside by that way. Okay, define the angle and define the extension length. The same at the bottom, you can make it like that, so you can extend and change the angle like that, or decrease it like that. So after that, we can change the transparency to make them visible by that way. Now if you try to make a thickness for that part, you will not be able to select the other faces because they are separate. They are separate faces, not connected faces. So we need to make a stitch to connect between those faces. So by selecting them and click on apply, now they are connected, and you can figure that you have a new surface, which is a stitched surface, which include those faces. And let's remove the transparency. Now if you click on thickness and click on that feature, you can give a thickness for this part, let's say 0.5 millimeter. Now you have a solid part by using the surface and stitch surface. So you use the revolve to create a surface. After that, we use the rolled surface to create some of rolled surfaces and make a stitch to connect the surfaces with each other. Now let's make a patch. So when you select this end, you can make a close end like that end. It will be closed end. And if you select that end, and from here you will find another options. If you would like to make this end as a tangent end or smooth end, you can make something like that. So from here you can figure that if we remove the transparency, you have a closed end by that way and another closed end right here. Now if we have let's say another plan, let's move this plan a little bit here, okay, and you would like to trim that with solid here. So if we click on OK, now you can figure that you trim this solid. And if you would like to reverse this one, here you can make, before that, let's make a stitch surface with that body and top and bottom here to combine them as a one stitch surface. So from here we can make, so after combining them, so let's remove that one, okay, and make a stitch between that and make it, remove the transparency. Now if you make a trim, select this surface, after that select the plan, sorry, let's select this one and select the trim surface, click OK. Now you can get a cut by that way, okay, or by removing, flip the remove to make a cut by that way. Let's make another tilted angle. So from here, let's select that plan and select the the XY plan and make a plan with 60 degrees like that. We have that angle. Let's increase it a little bit. Let's make it 80 degrees. Okay. Now, if you would like to make a slice cut here, and let's select trim, select that plan, and to remove the other face, you can figure that you can make a cut by that way. Now let's create a new project. This project including a heli-side nozzle. So we will create the shell as a plate, a nozzle from plate and reinforced bed. And let's make them as adaptive part. So we will learn how to make an adaptive part during this sample. Now let's create a new sketch, and from here let's create a sheet metal part, and from here let's create a new sketch. Let's make a circle, define the inside diameter as 2 meters. Okay, and from here let's convert this circle to work line. After that, create an arc, okay, and define the cut angle. Let's make it, let's say 5 millimeters, and let's define the orientation of this one. So from here we can make a line, define that to the vertical, and click on that, convert those to construction line and that small line to a construction line, and let's define the orientation of this one as 45 degrees. Now if we try to make a contour flange, so we can select this one. Before making that, let's change the thickness of that one to 14 millimeters and change the K factor to 0.5, and let's click save. Okay, now when we select contour, now you can figure that if we take a look from the side view, the thickness goes outside, so we can change it to inside or outside, or make it on the two sides. In our case, the value of the circle diameter indicates the inside diameter of the shell. And now we need to define the length of this course, so let's make 1 meter and make it in 2 equal sizes from the plan. Now let's click OK. Now if you try to get a flat pattern, you can get it easily by that way. Now let's make a work plan from that one. So let's move this one a little bit to, let's say, 1 meter and 200. So we have this plan. Let's create a sketch on that one. So from here, let's create a new circle and make this circle vertical to that datum point. Define it as 450 millimeters. Define the offset from here to there as 600 millimeters. And now if you click finish and create extrude, okay. Now by clicking on extrude and make it extrude cut to next, you will get this cut by that way. So when you make or create the flat pattern for this part, sheet metal flat pattern, you will get the shape like that. Okay, so let's say save this part as, so let's come back to the desktop here. Sorry, let's go to the desktop, create folder like shell part 1. Okay, now let's create another part, but in this time let's use the sketches that we created here and the work plane. So let's make those sketches and that plane visible, and from here let's create a sheet metal part. But that time let's open the manage tab, and from drive let's drive some information from another part. So from desktop let's select shell and select shell part 1. So from here we will get the same part, which is shell part 1. So let's remove the solids and include the sketches and the work plane, and the same for parameters. Let's include the model parameters and sheet metal parameters. Let's click on OK. Now we have those sketches, and let's create now let's convert this to a surface, and now we will proceed to create the nozzle surface. So from here we have this surface, and from that sketch, let's select that plan and let's create an arc. So let's project this circle and that line, and let's create a nozzle from here to there, and here we have a cut line in that area, so we can define the cut angle. Let's convert that line to construction line, and from here let's define that value. Let's make it 45 and define the arc length, which is, say, 2 millimeters. Now when we click on finish, okay, let's make that sketch invisible, and okay, so let's connect this one to that point. Sorry, so let's make that one here. Where is that line? Okay, okay, so let's connect this node again from here to there. Okay, and that edge to that edge. Now I think it's okay. Now if we make a contour flange and select this one, define the thickness to be inside. So let's reverse the direction to make the thickness to inside, and increase the extension to, let's say, 1 meter, and reverse the direction to make it like that. So let's minimize it a little bit. So I think it's okay now. Now let's make a cut for that one. So we don't need this extrude, so let's remove it and let's modify on that one. Let's create a circle and let's make extrude cut. So by using extrude cut along that one, so cut and through all. Now we have the nozzle neck as a nozzle from blade. Now if we get the flat pattern of this one, we will get the flat pattern like that. So let's come back and try to change the contour of the welding line. So if you get it on, let's say 180 degrees and click finish, now the cut line will be at the bottom. So if you get the sheet metal development, you will get it like that. Try to change it at 0. Let's make it at 0 and click finish sketch. The cut line will be at the top here. Now if you get the sheet metal development, you will get the sheet metal development by that way. Now let's save that part on the shell folder. So it's nozzle. Okay, click on save. Now let's create a new assembly. So from here, let's create a new assembly. Let's add the first part, which is shell. And let's add it placed at ground. Now let's add the second part, which is the nozzle, and let's add it placed at ground. So you can figure that it changes the orbit selection. So you will get that one like that. Let's keep this assembly. Before that, let's make those planes and the sketches invisible to make the view clear. So now you have this shell and nozzle like that without any 2D or 3D sketches or work plans. Okay, now let's add a rebad for this one. Let's save that assembly here. Shell assembly. Click save. Let's come back here and generate or make those sketches visible again. So from here, let's make those visible and let's create a new sheet metal part. And from manage, let's import a new the old part, which is the shell part from here, and remove the solid. And by using the sheet metal features, let's make a surface. Let's make a surface by using this circle. So let's go inside this one and from extrude, let's convert that to a circle, to a surface. And from here, let's define the value to 1 meter, make it equal spacing. And from here, let's create a new surface to next and make it like that. Now we have an intersect between those surfaces. So let's remove the transparency. And from here, we have an intersect between this shell and that shell. So let's make a trim to remove that part of shell to get this small area here. Now let's make that one visible. And by using extend, we can extend this surface. So let's make it as 20 millimeter width. Okay. Now we have this one. Let's add a thickness for this plate. And before that, let's update the thickness from here. It's 14 millimeters. It's okay. So now if we make a thickness and make it 14, looks like the that one, and make the thickness to outside. Now we have the thickness of the rebad, and now let's make a cut. So we have this sketch and make extrude cut through all. Now we have this reinforced pad. If we make the sketch invisible again and make the surface invisible, now we have this rebad. If we get the sheet metal development for it, if we click like that, we will get the sheet metal development of this nozzle. So let's save it as a rebad.
Okay, and let's assemble it with the final assembly of the nozzle. So let's save that one and come back here. Let's change the color of this one to smooth yellow and import it to the final assembly. So from here, let's import this repad, and by using flat on the right place. Now you can figure that we make a mistake, which is making the inside thickness of the shell is the inner thickness, inner surface of the repad. So we need to make a modify here for that surface, because we define this surface as the shell ID. So we need to modify that one. So let's come back here and convert that one to another surface like that, and create a new circle. Okay, and define the outside diameter here. Let's come back again, sorry, and define that as a diameter. So from here, select diameter and define that as 2 millimeter, twice the thickness. Okay, and that's the surface. Now if we come back here and let's modify the surface and select the new one, we will get that one, and let's modify the trim. So let's move that up. Let's make the surfaces appear again, sorry. So from here, let's modify the trim first. So from trim, let's remove that face. So let's use trim in that one and that one. We will get that face. So let's make that one invisible, and let's come back here and modify the extend. So let's select the edge and come back to the thickness. We'll select the face again. That's the thickness, and now finally we have the cut on this repad. So you will get this one, and here we have the flat pattern at the right place. Now let's come back to the unfold face, and when you come back to the shell, you will get the repad located on the right place. Now let's make those planes and that plane and those sketches invisible, and let's check the final assembly here. So we have this sketch like, or the 3D model of nozzle and shell like that. If you come back again to the 3D model and try to change that offset, let's make it 40 millimeters, for example, and increase the diameter of this one to 600 like that, and click finish. Now if you come back to the assembly and click on update, automatically the other parts will be updated depending on the change on the driven sketch. Okay, so let's try that again by, let's minimize that to 150 and click on finish. Now if you come back to the assembly and update, you will get the update by that way. So by using the adaptive part, we create that file. Okay, let's go to the next step. Here we have this type of nozzle. It's a conical nozzle connected to a head, and this conical nozzle is a tilted one. After that, connected to a straight pipe neck from blade, and we need to generate the actual cut here, because if you take a look to the cut of the nozzle with the head, it's not looks like in real. You can figure that you have much curvature here for the cut of the head with the head opening for the nozzle. So let's start proceeding creating this one. We have a head with inside diameter 3 meters 0.6 and thickness 25 millimeters. So let's close this project and save. Let's create a new project, create it on the desktop and single project, and let's make it cone. Create it on the desktop and create \cone. click on finish, and Autodesk Inventor will inform you that project will be created from scratch. Now let's create a new sheet metal part, and from here let's create a sketch, create a center line, define this one as a center line, draw the head contour. So from here let's make a knuckle radius. After that, create the crown radius. Let's connect this point to that one, and from here let's make the center line of this head located on the extension of this line. Now let's make that one as a construction line. Define the inside diameter of this head 3 meters 0.6. Define the knuckle radius as 0.17 times the diameter, and the crown radius as 0.9 times the inside diameter. Now we have the curvature of the head. Now let's start creating the cone. We have the center line of the cone here and the end of this cone, which is located on the line. So let's connect this one to the head here, and the offset of that one, you can figure that you make that as a center line, but on the drawing it's from one side, not a diameter. So to avoid making it like that, you can select remove the linear diameter to define this dimension like that. And at the top it 1360, so it's 1360 like that. And let's make the outside diameter at the top, which is 929. So let's come back here, draw a line like that, connect this line from the middle, define the aligned value, which is 929. So 929. So okay, and at the bottom we have that line, which is 608 and 9, and the end of that one is connected to the shell, and the extension of that line located on that nozzle. So let's modify this one a little bit and connect those lines like that, and create the top nozzle from here to there, and define the tilted angle from here to there as 10 millimeters. Now define the projection from here to the tan line 160 millimeters, and that length it's 300 millimeters. Now we have the cone shape like that, and that's the 2D view for that one. Now let's create a loft part by making a circle at top and another one at bottom. But before that, let's create a line perpendicular to that line from the center. So let's be sure that one is perpendicular here. Okay, convert it to a construction line. The same here, let's make another line. Be sure that line is perpendicular to that one and make it as a construction line. Now let's create a plan perpendicular to that line at the end, and use this plan to create a circle. So by clicking on F5, you will get a previous view, and by printing those points, you will get a circle at the top like that. The same thing we will do at the bottom. By selecting this line and the end point, we can make a perpendicular plan on that line at the end and create a new sketch on that plan. By clicking on F5, you will get a view back again. So by printing this or project this point here, you can print the center point of that one like that. So let's select that one from here to there. Now we have those two circles. Now let's make those sketches invisible right now, and by using the loft order, you can make a loft between those surfaces, but let's make it as a die format. And let's define the thickness of this plate before going to develop it. So from here, let's define that as 25 millimeters, and the K factor will be 0.5. And let's click save, and the material from here is steel, and click save, and the color will be steel. Now let's create a loft and select that one, and make it die format, and let's flip the thickness to inside, so keep the dimensions for the outside. Now we have that cone like that. Now if we select, for example, the inner or outer circle and add a point at the end right here, and click on finish. Now if we make this sketch visible again, okay, you can make a rib for the outside surface from that gap. Let's define this gap as 2 millimeters. Now if you try to get the flat pattern for this cone, you will get it like that. Now we have this sketch for top and bottom, so let's make all of that visible again, and let's create the second part. So let's save this part here as a cone part. Now let's create the pipe as the top here with a chamfer end by using the same sketch. So let's create a new sheet metal part, and from manage, let's drive the sketches, and if we have a work planes, we can include it, so we can include that and include the parameters for the sheet metal and the other parameters. Now we can generate a plan through that line and perpendicular to or parallel to the bottom line, so you can make it with a 0. And if we create a sketch here and click on F5, we can project this line, so from here we can select the end of that line and the center to make a circle like that, and let's make all of those invisible, and let's make a contour here for this one. So let's take a look from the top view, convert that one as a construction line, and from arc let's create another cut. Let's define that as 2 millimeters. Okay, and now let's click on finish. Now you can, if we make that one visible again, like that, you can make a contour for that selected shape, and you can figure that the thickness goes to outside, so we need to flip it to the inside like that, and flip the direction like that, and extrude it with 300 millimeters. After that we can make a cut, so we have a line here, so we can use this line directly to make a split. So by using split tool and the second type of split, which is trimming the face, we can select this line, and you can figure that you can make a trim for the top or bottom part. We need to make a trim for the bottom part, so we can remove it like that. Now if you get the flat pattern for this part, you will get that option. Now let's come back again and save this part as nozzle or nozzle plate. Now let's create the shell, the head, and create the cut on the head. Now let's create a new assembly and add those two parts and make them place at ground. So we have those two parts here like that, and we need to add the head with a cut. So let's create a new part, and from here let's create a standard part, and from manage let's add drive and select the cone. Let's remove that and remove the parameters, we don't need them, but from here we could select the work planes. So from here we could use the first sketch of the head. So if we come back to revolve and select that sketch, so we can make a surface. So by selecting this one and selecting the curve, we can make a surface like that and give it a thickness. So by selecting that way, we can define the thickness as 25 millimeters, and it goes to the outside like that. So we have two sketches here and there, so we can connect between them by using the loft. So from loft, let's select that sketch and that sketch and make them as loft with cut, not as a join. If you click OK, you will get a cut like that. Let's make all of that invisible, and let's come back to the assembly and import this head. So let's save the head first. So it's head. We come back to the assembly and import the, okay, like that. We have this head with a cut. Now let's make those sketches invisible again. If you come back here to the final assembly, you will get that one by that way. I hope this sample become clear, and you can figure that the cut on this one, if we take a cross section, a half section here along that plan, you can figure that the cut curvature here not looks like the AutoCAD drawing, because here it's a roughly sketch. It's not the actual curvature according to the cut, but here with Autodesk Inventor you get the actual cut of the this conical nozzle on the head. Okay, now let's make a sample, another sample for a 3D part, and let's open the project folder. Here we have this drawing. This bearing bracket, we have four parts. The first and the third and the fourth part, they are the push parts, one at top and bottom, and another cover, and here the body of that one. So let's create those parts. So let's close that, and from here let's create a new standard part, and from sketch let's create a new sketch, and from here let's create a rectangle. This rectangle we will weld this middle point at here, convert this one as a center line and those as a construction line. Now let's sketch the contour of this one to be like that, roughly sketch. After that, let's add the dimensions. So from here, the inner diameter is 32. So from here to there, it's 32, and that one is 6 millimeters. The length of this one, sorry, the length of this one is 1 like that. So let's move this one a little bit here, and the thickness of this one equals that one. That's 6 millimeters, and that from here to there is 6 millimeters. So if we measure the diameter here, it's like that. It's 45. So let's come back again. That's 38. Okay, so let's check that again. That's 10, and from here it's 38. So let's delete this and make that as 38. Okay, and click on finish. Now let's make a revolve for that one. Sorry, the value here is the inside diameter, so it's times 2, and here it's, sorry, it's times 2. So now let's finish that and make a revolve, but that time let's make it with 180 degree and make it on the two sides. Change the material to brass. So from here it will be like that, and we have a cut at the top. We have a hole at the top, so we can make that from the top plan. Let's make a circle at here, and let's flip the view. Define that one as 10 millimeters. I think it's 10 millimeters. Okay, and make extrude, cut, and make it through all. And now we have the first part. So click save and gearing. Sorry. Gearing bracket. Push part 1. Okay, and let's save that one as push part 2. So push part 2. And let's make a modification. Let's delete this one from push part 2 and make it as an extend. So from here we have that plan at the bottom. So let's make another one here at the end. So we have 38 up to the end surface, and the extension of this one is 6 millimeters. So we will add 6 millimeters like that, and let's select this plan and make a sketch for a circle with 10 millimeters diameter and click extrude and make that one to next, to make this extrude to next like that. And let's click on save. Let's make this plan invisible, close this part, and let's create a new solid part. Okay, and create a new sketch. So from here, let's creating this one. Okay, so from here, let's make an arc like that. Make those points on a horizontal level. Define the inside diameter, so it's 38. So the inside radius is 38, and we have edges here. Sorry, it's a straight one. So let's make it a vertical like that. Make that one like that. Make the same on the other side. Select this edge and that edge, make them equal. That one and that one, make them equal, and the same here, make them equal, and those make them linear, the same level. And let's come back here. So the width here is 88. So from here to there it's 88, and that one is 7 millimeters. Okay, and that it's 20 millimeters thickness, and the total width here is 88 times 2 and 44 times 2, so it's 88 plus 24, all that times 2, and don't forget to add another bracket here. So we have this one, and we have another arc at the top here with radius 58. So let's add another arc here with a 58 millimeters. 58, and now let's connect those ends from here to there, and let's make a fillet, and that fillet with 12 millimeters from here to there, and another one from here to there. Now we have this part. Now let's click finish. We have this sketch. Let's make an extrude, make it symmetric, and let's add the width, which is 114. Now let's make a fillet to the end edges, and the value of the end edges is 24. So from here it's 24 millimeters, and let's create a sketch at the top to define the pooling here, there. Okay, and let's add some nodes like that. Convert that to a construction line, click finish. Now if we select the hole, we can create that hole with diameter 16 millimeters and click OK. Now we have this part. We just need to make that cut at the top, so we can make it we can make that hole by drawing that cut on that one. So let's create a center line, define that one will be like that, define that one as a center line, the diameter of this one as it's 10 millimeters diameter. Okay, and that angle is 45 degrees. Okay, and the height from here to there is 5 millimeters. And that point located at the arc, so we need to print this arc, convert it to construction line, and weld that one like that. Now if we click a revolve for that and make it cut, we will get that shape. Now we create this part, so let's save it as a cover. Let's create a new part, which is that one, which is the body. So let's create this support first. After that, we can create the base. So from here, let's create this one, and from the arc, let's create that one. Make those points on the horizontal level. Let's make those wings here and there, like that. The same from the other side. And let's define the inside diameter as 38. Okay, and this edge as 88. So from here to there, 88, and make those lines equal. Those lines equal. Those lines equal. And here that will be that will be 6 millimeters. Okay, and the total width from here, it's 24 plus 88 times 2, so you will get that one, and the thickness is 20 millimeters, so that one is 20 millimeters. Now let's make another sketch, so let's make that one like that. And from here, let's make the center point comes here, make those lines are equal. Okay, now we need to modify that, make this line equals that line at distance, and the same between that. Okay, no problem. Now let's define the bottom width. So the bottom width is 290, so 290, and the height 203. Okay, from that center line, and we need to reduce 25 millimeters, which is the base thickness. So from here to there, 203, and we need to reduce 25. Now I think it's okay. We need to make a fillet with 12 millimeters. So from here, let's make a fillet 12 millimeters between that one and that one. The same from here. And now we have that one. To define the location of this one, we need to draw that hole, because the center of that hole ends at the end of the bottom straight edge. So from here, let's come back and draw this rectangle like that, and let's add a center line from here to there. Define the inside diameter of this hole as 14. Okay, and make the end of this one to the end. Sorry, let's make this line located at the end of that one. So if we move that, it will move like that. Okay, it's okay now. So let's define the location of this hole from the edge. It's 24. So it's 24. Now we fix this one, and now when we click finish, and you can we need to define the ribs. So we need to make lines like that, another arc, and we need to make an arc from here to there, and another tangent arc like that, and a line from here to there. Make those lines parallel, those lines parallel, and this arc tangent to that one, this arc tangent to that one. Make those arcs equal. Define the arc value 12, and here it's 58. So this one is 58 and that one is 12, and the thickness here is 16 millimeters. The same on the other side, it's 16. Now we have this sketch fixed, so let's finish that one and extrude that one and make it on one side. And if we take a look, if we take a look to the extrude value, 24 and plus 33. So let's open 24 plus 33, all of that times 2. So that's the extrude here, and let's create the bottom part, or we could make the fillets and holes first. So from here, let's select both edges, and let's define the fillet as 24 millimeters. Click a sketch at the top and project the fillets to get the center of the holes. So we have holes at the center here. Let's convert the construction lines. Click finish. Now if you select the holes, you will get those holes, and you can increase the hole length by that way, but it's okay now. Now let's create the bottom base. So from here, let's create a rectangle. So you can select that end. Sorry, we can select that end and extend this one. And from here, let's weld this one. So let's define the that value, which is, sorry, let's come back again to the sketch and define that value 207. Make extrude for that one with 25 millimeters. Now we have this face. Now we need to make the cut at the bottom 143. So let's select the bottom and create a sketch. Now let's make a rectangle, and let's make the center point aligned horizontal with this one. So let's select this one, make it aligned. So the width here 143, and the length here is 240. So it's 240, and the offset from the end it's 290. So 90 or 80. I think it's 80, not 90. So we come back here to the previous sketch, which is that one. We can change that to an 80, and the other one will be changed. So if we come back here, we can calculate the offset from that one. Yeah, it's already centered, okay, but on the other side we have 23 millimeters. From here 32, and for the other side it's 32. So let's click finish and click extrude, but this time we will make it extrude cut and define the groove with 6 millimeters. So we will have 6 millimeters groove. Okay, after creating the holes, we can make the fillets. So from here, let's create the holes. We have one hole at back at the center here, and two holes that direction. So let's make this hole aligned vertically, aligned vertically with that one, with an offset from here 32 millimeters. Here the offset of groove is 20 only, not 32. The 32 offset is a hole. Sorry. So we can define it after that. So, but let's define that one as 32 right now. Those are 32, and they are in horizontal position, and the spacing between them is 2016. So between that one and that one, 2016. And to measure the offset from here, we can make an equation which 280 negative 216 divided by 2. So we can calculate the correct place right now. Now we have those holes. Now you can make the cut for holes with 16 millimeters offset. Now let's come back to the cut at the bottom. Define this one as 20 millimeters. sorry, it's 30 millimeters. Okay, 32. It's 32. Okay, so that one, it's not in that value, so it's 20 from the two edges, so 20 from here and there, and let's click finish. Now we have those holes. Let's make the washers at the top, so let's project the holes. We have those holes here. Okay, let's come back again here. I think this one should be 20. Okay, now if we come back to that sketch, let's delete those circles and create them again. So by project, create them, and let's create the outer diameter of the washers. Select the three holes like that and make them equal. And now you can define the diameter of this one. The diameter is 38 for one of them, and they are equal. Now click finish. And the thickness of this washer is 3 millimeters. So extrude, click on extrude, and select those as 3 millimeters width. Now we have that one. Now we need to make this rib, tilted rib. This edge is not straight. We need to make this rib. So from here, let's select this surface, and let's select this node from here, and let's add a line to the end of this arc. So let's weld the end from here to that one, and let's define that value from here to there. It's 146, so it's 146. Okay, and let's convert those to construction lines. Now click finish. Now if we give an extrude for that one with a 16 millimeters, the same rib thickness, but with the other direction, like that, you can figure that we have this extrude. Now you can make a mirror for that one to the other side, like that. Now you have the ability to add the other fillets to the bottom. We need to add one more thing here, which is a hole. We have the hole at the middle here, and we have a web. So before that, let's make a work plane between those surfaces. So let's select that one and that one. Now we have this work plane. Let's make a sketch, and let's print those edges from here to there, and let's make a new arc like that, and make another tangent arcs from here to that line, from the end to that line, and let's make that by that way. Let's define the dimension. So it's 76, the radius here, and the fillet radius is 38, and they are the same. So we have that one like that one. So let's make extrude. Let's select the closed area, and you can figure that the thickness will come on that side, or you can make it on the other side, but actually we need it on the middle, because this rib is on the middle. So let's make it like that and click OK. Now we have that web at the middle. Now let's make the cut of the hole. So let's make a slice graphs and make the hole that we need. So we have a hole like that, okay, which is that hole, and the depth of this one is 10 millimeters. So if we add a point from here, that one, and measure from here to there, we need 10 millimeters. Sorry. Let's remove this one, and here we have that edge. So let's add a construction line here. Okay, and measure the distance from here to there as 10 millimeters, and make that one as 60 degrees, like that. Define the diameter. So let's convert this to construction line. After that, define that one as 10 millimeters. Now if we make a revolve for that one around this axe, but make it with a cut, we will get the result of that one. Now we have those parts. Let's save that one. Before saving it, let's make the fillets. So let's define the fillet. We have the fillets here as 12 millimeters as the inside. So let's select those edges and those edges here and there. Let's define them as 12 millimeters. Okay. We have another fillets at bottom with 5 millimeters. So let's define that as 5 millimeters and select a loop to select that loop here. Okay, to make a fillet here, or let's decrease it a little bit, make it 4 or 3. Let's make it 3 millimeters. So we have a fillet with 3 millimeters. So sorry, we select that edge. So we need to remove it. So let's remove it and click on save. Okay, now we have this part with fillets, and let's add more fillets for that with 2 millimeters fillet. So we have that part by that way. Now let's save this one as a body. Now let's create a new assembly. So from here, let's select standard assembly, and let's base the bearing. So from here, let's add a body and place at ground. Now we have this part. Now let's add the first part, which is the bottom wash. So from here, let's add this one, and from constraint, let's select insert, select this edge and that edge, and now you can figure that the number of degree of freedom is decreased. So let's make it visible, and let's undo that again, and before that let's make the degree of freedom appear. So we have 6 degrees of freedom, 3 degrees of freedom in X, Y, and Z, and orientation around the 3 axes. So from here, let's make insert for that edge with that edge, like that. And now the degree of freedom decreased to 1, from 6 to 1. And now let's make a flush for that surface with that one. Let's import the second wash at the top. So from here, let's make the center line of that one with that one, and make that face with that face. So you can figure that you can still have to another degree of freedom you need to fix. So from here, let's make that face mate that face. So now that part is completely fixed. Now let's add another part, which is the cover. Now we have this cover, and from here let's select insert, select insert this face to that end. Now we have that one, and we still have 1 degree of freedom. Now let's select another constraint, which is edges, angle, and make this angle parallel to that one. Now we have this part fully constrained without any degrees of freedom. Now let's save it as bearing bracket simply. Okay, and let's create a drawing. So from here, let's create a drawing. Let's add this one at that view. Let's increase it a little bit. Okay, and let's make another view from here, there, and 3D view. Let's add a bill of material. So from here, let's add a general. Let's add a part list. Select this one, select parts only, and add it here. Now we have the part names. We need to modify at this. Let's remove the description and add material. So let's add the material and the mass. Now let's change the width of that one a little bit. Let's make it 15, and that one let's decrease it a little bit. Let's make it 30, and for that one let's increase it a little bit. Let's make it 40 millimeters. And for the mass, let's modify it, make it like that. Make it dot without that one. Remove the unit and define the width to be 20 millimeters and click OK. Now we have this bill of material, which includes the material of each part, name of each part, and the mass. We need to change the material of the body and the cover to steel. So let's come back to the body, and from here let's change the material to steel and the color to steel. The same for cover. Now when you change it to steel and color to steel and come back to the drawing, here you can figure that materials are changed and the weight change for this part. Now by that way we create a quick drawing for this support, and I hope inshallah this session covers a lot of your needs regarding the sheet metal and the adaptive parts. Thank you for your time. Have a nice day. Bye bye.